In the winding Mississippi River and its tributaries in the central United States, a strange scenic line is enough to leave any first-time visitor stunned. The roar of the engine swept across the peaceful water, and in an instant, it was as if a bomb had detonated underwater. Dozens or even hundreds of shimmering silver giant fish jumped out of the water with a resounding sound. They are like missiles launched by invisible springs, rushing into the air nearly 10 feet high. Chaotic collisions with boats, guardrails, and even frightened fishermen. This is not a special effect seen in Hollywood sci-fi movies, but a common reality in this water area today. The creator of this silver storm is the invasive species that Americans are terrified of talking about, the Asian carp. They are not a single fish species, but a collective term for several cyprinid fish species. Mainly including silver carp, bighead carp, grass carp, and green carp. These former foreign helpers, in just a few decades, evolved into the most terrifying ecological nightmare in the waters of the United States mainland. They are devouring the survival foundation of local species and changing the ecological landscape of rivers and lakes. However, under the shadow of this ecological crisis, an unexpected dawn is emerging. Entrepreneurs, scientists, chefs, and ordinary people are trying to turn this unprecedented disaster into a disaster, transforming into an economic opportunity worth billions of dollars. This war against Asian carp is not only about ecological restoration. It is also a grand narrative about innovation, adaptation, and re-examination of the relationship between humans and nature. This is a story about mistakes, consequences, and redemption. A classic case of finding a turning point in a crisis. Its experience and lessons have important reference significance for global biological invasion prevention and control. To understand why Asian carp have become a nightmare for the United States, we must turn the clock back over half a century ago. Looking back at the history that was full of goodwill but ultimately turned into bitter fruit. In the 1960s and 1970s, the catfish farming industry in the United States faced a thorny problem. Excessive growth of algae and aquatic weeds in aquaculture ponds affects water quality and fish health. When seeking low-cost and sustainable solutions, American aquaculture managers have turned their attention to the east. In China and Southeast Asia, silver carp, mainly filter feeding on phytoplankton. The bighead carp, mainly filter feeding on planktonic animals, is known as the pond cleaner. Its efficient filtering ability is the perfect answer to solving the algal bloom problem. Grass carp are considered for waterway cleaning due to their habit of feeding on aquatic plants. So, with the mission of biological vacuum cleaner, Asian carp officially introduced into aquaculture systems in southern states of the United States. In the initial stage, they did live up to expectations and worked diligently in a controlled breeding environment. Effectively improved pond water quality and became a reliable assistant for aquaculture farmers. During this period, no one foresaw that these gentle cleaners would one day create a storm in the future. However, the seeds of disaster have already been planted. These carp are kept in farms and oxidation ponds scattered along the river banks. The design standards for these facilities did not fully consider extreme weather events. In the early 1990s, a series of rare and catastrophic floods swept across the southern United States, especially in the Mississippi River Basin. The surging flood is like a wild horse that has lost its reins. The fragile pond dam was washed away, and thousands of silver carp, bighead carp, and grass carp were washed into the vast Mississippi River system, once entering this well-connected natural water area. Asian carp, like dragons, enter the sea and find their paradise. The Mississippi River has fertile water, suitable temperature, and almost no natural enemies, provided them with an unprecedented ideal habitat. Their biological characteristics that were originally used to clean ponds, becoming a terrifying invasive weapon in the natural environment. These features include amazing reproductive ability. A mature female carp can lay up to 1 million eggs in one breeding season. These eggs float and hatch with the water flow, and the survival rate increases sharply with the expansion of the population base. This R-selection strategy, focusing on breeding quantity rather than offspring nurturing, is particularly deadly in resource-rich new environments. Strong adaptability. They have strong tolerance to changes in water temperature and quality, and can quickly occupy ecological niches in new environments. From the warm southern waters to the relatively cold northern tributaries, they demonstrate astonishing adaptability. Competitive advantage of food. Their filtration efficiency is extremely high, which can effectively filter tiny plankton from water. Its efficiency far exceeds that of local filter-feeding fish. With these advantages, the population of Asian carp began to experience explosive growth. They swim upstream along the Mississippi River and its countless tributaries, like an unstoppable army of silver. Wherever they go, the ecosystem is transformed. By the late 1990s, they had formed an absolute dominant population in many sections of the Mississippi River Basin, laying the groundwork for the subsequent ecological crisis. Why can Asian carp cause such a huge ecological impact? We need to start with their biological structure. They can be regarded as perfect machines built for survival and expansion in the history of evolution. Understanding these characteristics is the foundation for developing effective prevention and control strategies. Plankton harvester, a fundamental blow to the food chain. Adult silver carp and bighead carp are efficient filter feeders. Their gill rakes have an exceptionally precise structure, resembling a fine sieve that can filter out micrometer-sized plankton in water. An adult silver carp can filter and feed on water equivalent to 20% to 40% of its body weight every day, ingesting tiny phytoplankton and zooplankton from it. Considering that these fish can grow up to tens of pounds, the amount of water they filter per day is quite astonishing. Plankton is the cornerstone of the freshwater food chain. From tiny aquatic insects to larger bait fish. From top predatory fish such as bass, trout, and salmon. The energy flow of the entire ecosystem begins with planktonic organisms. When millions of Asian carp act like giant biofilters. When constantly peeling off these basic foods from the water day and night, they are actually emptying the bottom of the entire food chain. The direct consequence is that local fish species, especially for juvenile fish and specific fish species that also rely on plankton, such as yellow bass, American herring, etc., faced with severe food shortages, slow growth, and a sharp decline in population size. This kind of bottom-cutting competition is the main reason for the decline of many precious native fish species. Ecologists refer to this phenomenon as the nutritional cascade effect. A change in nutritional level triggers a shock throughout the entire food chain. Breeding perpetual motion machine, a strategy of quantity crushing. The breeding strategy of Asian carp is a typical case of quantity over quality. They invest their reproductive energy into producing a massive number of eggs, instead of carefully nurturing a few offspring. This strategy is particularly deadly in new habitats with stable environments and scarce natural enemies. A population can grow from the first few hundred individuals in just a few years. Exponential growth to millions of dollars. In some sections of the Illinois River, the biomass of Asian carp accounts for over 90% of the total fish biomass. This explosive growth has led to traditional control methods. Like commercial fishing or selective hunting, it becomes a drop in the bucket. Like trying to extinguish a forest fire with a glass of water. Their reproductive success is also attributed to the extended breeding season and adaptability to various hydrological conditions. Ensure maximum reproductive success rate under any favorable conditions. Stress jumpers, physical threats to people and devices. Silver fish are extremely sensitive to low-frequency sounds and water vibrations. This is an instinctive defense mechanism used to deal with potential predators. The vibration of ship engines can be mistaken by them for the approach of large predators such as finless porpoises. This triggers crazy jumping behavior. This jumping ability is not only a spectacle, but also a real danger. These fish bodies weighing tens of pounds collide at high speed. Capable of injuring crew members, damaging onboard equipment, and even causing small boats to lose control. This has greatly affected commercial shipping and leisure tourism on the Mississippi and Illinois rivers, transforming ecological issues into public safety concerns. Passing ships have to install protective nets, and crew members need to wear safety helmets. These additional protective measures increase operating costs and security risks. The hanging sword, the urgent crisis of the Great Lakes. The northward movement of Asian carp ultimately points to the freshwater heart of the North American continent, the Great Lakes. This vast body of water accounts for 21% of the world's surface freshwater resources, supporting a fishery worth up to $7 billion, and provide drinking water for over 40 million residents in the United States and Canada. The Great Lakes are not only a natural wonder, but also an economic and cultural lifeline. At present, the vanguard of invading fish schools has arrived at the complex artificial waterway system in the Chicago area. The Chicago Sanitary and Shipping Canal, CAWS. Here, they are separated from Lake Michigan, one of the Great Lakes, by only a gate. The U.S. government has established electronic barriers here as the main line of defense. Biologists issue stern warning, even if only a few pairs of breeding individuals successfully cross the barrier and enter the lake area, it is possible to establish a self-sustaining population. The DNA Environmental Monitoring, EDNA, technology has repeatedly detected the genetic material of Asian carp on the side of the barrier near the lake area. Although it has not been confirmed that a live breeding population has been established, this undoubtedly sounds the alarm. Once Asian carp take root in the Great Lakes, its huge consumption of plankton will directly compete with key fish species such as lake red salmon, yellow bass, and western herring. May lead to the collapse of the entire fishing industry and trigger a series of unpredictable ecological chain reactions. What is even more worrying is that the plankton community structure in the Great Lakes is different from that in rivers. Perhaps more fragile and susceptible to disturbances. The consequences will be catastrophic and irreversible. This has prompted the United States and Canada to consider the defense of the Great Lakes as the highest priority ecological security issue. faced with the invaders approaching step by step. Various levels of government, research institutions, and civil society in the United States have launched a comprehensive defense war. This war is not only happening on water, but also on the battlefields of laboratories, markets, and public consciousness. The coping strategies exhibit multi-level and interdisciplinary characteristics. Physical and engineering barrier, building the Maginot Line. This is the most direct and largest defense line invested. Intended to physically block the diffusion path of carp, especially the main road leading to the Great Lakes. Electronic barrier, in the Chicago shipping canal connecting the Mississippi River system to the Great Lakes. The U.S. government is spending billions of dollars to build and maintain the world's first underwater DC barrier for fish protection. It generates a low-voltage electric field underwater, which strongly repels approaching fish. Form an intangible force field. At present, multiple barriers have been deployed in the area to improve reliability. However, this barrier is not foolproof. Juvenile fish, fish eggs, or under specific water flow conditions, such as during floods. There is still a potential for crossing. The continuous maintenance and power supply costs are also very high. Bioacoustic deterrence, researchers are testing the use of specific frequency sounds to drive away Asian carp. Play predator sounds, such as oars hitting water, or their own warning signals through underwater speakers, can effectively change the direction of fish movement. But this method may have a negative impact on local aquatic mammals such as dolphins and whales that are sensitive to sound. Therefore, careful frequency selection and site evaluation are required. Bubble curtains and water guns. Other physical deterrence technologies include manufacturing dense bubble curtains and high-pressure water guns. These methods are usually used as auxiliary means, used in specific areas to enhance the effectiveness of the primary barrier. Biology and genetic control, precise strikes for the future. In order to find more targeted and sustainable solutions, scientists are exploring more cutting-edge fields, and most of these methods are still in the development and evaluation stages. Gene drive technology, research stage. This is the boldest and most controversial idea. In theory, scientists can use gene editing techniques such as CRISPR. Create a selfish gene targeting only Asian carp. This gene can rapidly spread in wild populations, ultimately leading to a severe gender imbalance in offspring, e.g., all becoming male, or infertility, thus causing the population to collapse at the root. However, this technology is still in the early stages of research. Its potential ecological risks, ethical issues, and regulatory framework are extremely complex. There is still a long way to go before practical application. Specific pathogens, searching for a virus or bacteria that only infects and kills specific species of Asian carp is another research direction. This requires extremely strict biosafety controls to ensure that pathogens do not accidentally leak or mutate. Fish species of the same species or other non-target organisms that pose a threat to their place of origin. Currently, scientists are systematically screening for potential pathogens that Asian carp may carry. Assess its potential as a biological control agent. Commercial fishing and market development, transforming enemies into assets. While attempting to stop the carp, a powerful force is working to extract them from the water. Become a valuable commodity. This is the most creative and potential coping strategy, intended to utilize market forces to provide sustained momentum for ecological control. The rise of commercial fishing industry. In carp-intensive areas such as the Illinois River, professional commercial fishing fleets have formed. They use large nets and customized fishing gear, which can capture tens of thousands of pounds of carp with just one net. This not only directly reduces the population size, but also provides raw materials for the subsequent industrial chain. The government sometimes provides subsidies or sets purchase prices to ensure the economic feasibility of fishing. Export market expansion. In Asia, especially in China, silver carp and bighead carp are popular traditional ingredients. Processing companies in the United States will capture carp that have been finely processed and rapidly frozen. Large quantities are exported to these regions. This has formed a stable demand market, provided economic incentives for fishing activities. Establishing a cold chain logistics and processing system that meets the standards of the target market is key. Local market cultivation and product innovation. Changing the mindset of American consumers is a greater challenge, but it is also a necessary path. Education for the public, through media promotion, food festivals, promotion of renowned chefs, and school education. Educate the public about the nutritional value of Asian carp, which is high in protein, low in fat, and low in mercury. Break the stereotype of being a junk fish. Deep processing of products, to overcome the American mentality of being tired of prickly fish. Processing companies use mechanical deboning technology to make fish paste from carp meat. Fish balls, fish cakes, fish-flavored sausages, fish burger chops and other boneless products. Even develop dried fish, carp bacon, and high-end pet food, greatly expanding the product range. Brand reshaping. Some marketers suggest giving Asian carp sold in the United States a more attractive new name, such as silver scale fish or Kentucky snapper, to get rid of their negative image. This is a successful strategy in the history of food, such as the Patagonian toothfish, formerly known as Chilean sea bass. Leisure and ecotourism, turning burden into entertainment. Transforming the issue of carp invasion into a unique tourism experience. It is another clever strategy that not only controls the population, but also it can also enhance public participation and create economic benefits. Crossbow and fish shooting exercise. In areas with dense carp populations, crossbow and fish shooting has become an extremely popular extreme sport. Enthusiasts stand at the bow of specially designed boats, shooting carp that jump out of the water or are clearly visible underwater with special bows and arrows. This sport not only stimulates, but also directly participates in population control. It has attracted a large number of domestic and foreign tourists, driving local tour guide services, equipment sales, and accommodation and catering industries. Rural fishing championships, events like those held in Bath, Illinois, encourage participants to participate in the most primitive way possible. Fishing nets, harpoons, and even bare hands, catching carp. It's more like a community carnival with bonuses and entertainment activities. Enhanced public participation and awareness of invasive species issues in a relaxed and pleasant atmosphere. Transforming a challenging environmental task into an engaging community activity. Policy and legal framework, the foundation for building a defense system. Effective management cannot be achieved without strong policy and legal support. The Lacey Law. This federal law effectively prohibits the cross-state live transportation of a range of invasive fish species, including Asian carp, fundamentally cutting off an important pathway for diffusion through commercial trade. Law enforcement agencies crack down severely on illegal transportation activities. Large-scale public investment. Federal and state governments, such as Illinois and Michigan, continue to invest heavily. Construction and maintenance of barrier facilities, scientific research, and establishment of population monitoring networks, including EDNA technology, covering vast water areas. These investments are the lifeblood that sustains the defense system. International cooperation. The United States and Canada have established close cooperation on the protection of the Great Lakes. Through mechanisms such as the International Joint Commission, IJC. Joint funding, data sharing, and collaborative research to address the threat of Asian carp. This reflects the collaborative governance of cross-border ecological issues. Despite the seemingly bright future, the road to transforming Asian carp from disaster to resource is full of thorns. Filled with complex ecological and economic paradoxes. No single solution is effective, and the pros and cons of various strategies must be carefully weighed. Firstly, the paradox of harvest. This is a core dilemma. We hope to reduce the number of carp through commercial fishing. But a profitable fishery relies on a stable and even sustainable fish population for its long-term existence. If the fishing is too successful, it will lead to a significant decrease in the number of carp to a commercially unprofitable level. Fishing activities will stop and the population may quickly rebound. This raises a fundamental question. Are we going to eliminate them or manage them? If the goal is eradication, then commercial fishing may not be a perfect tool. Because it may lose economic momentum before achieving its goals. If the goal is control, then we need to establish a system that can operate for the long term. A business model that can still generate profits even at low population densities is highly challenging. Next is the challenge of market development. Despite the existence of export markets, they face many obstacles. International market price fluctuations, changes in trade policies, high logistics costs, and processing technology barriers. All of them affect the stability of the industry. More importantly, it is difficult to cultivate a consumer market in the United States. Americans' dietary habits prefer fish with fewer spines and flaky pieces, such as cod and salmon. There is a deep-rooted prejudice against prickly carp. Changing a generation's dietary preferences is not an overnight effort. Continuous investment in market education and product innovation is required. Balancing cost and benefit. Billions of dollars in public funds are invested annually in electronic barriers, scientific research, monitoring networks, and management projects. Critics question the use of these huge funds to restore native fish habitats. Strengthen ballast water management to prevent other invasive species. Or to address broader environmental issues such as climate change. Would it be a better investment choice? This is a typical resource allocation challenge that requires making difficult choices within a limited environmental budget. Evaluate the cost-effectiveness of the Asian Carp Prevention and Control Project. It must be compared to the enormous economic losses that could result from invading the Great Lakes. The risks and ethical dilemmas of technology. Although cutting-edge technologies such as gene drive are powerful, their irreversibility and potential risk of gene contamination are worrying. Once genetically modified organisms are released into the open environment, its behavior and development are difficult to predict and may have unpredictable consequences for the entire ecosystem. Public acceptance, international regulatory consensus, and cautious attitude of the scientific community. All of these make the application prospects of such technologies full of uncertainty. This has triggered profound ethical thinking. Do we have the right to correct an ecological mistake? And using such powerful technology to permanently change a species or even an ecosystem? The story of Asian carp in the United States is a mirror reflecting the era of globalization. The profound and often unpredictable impact of human activities on the natural environment. It tells us that a well-intentioned local decision may trigger an ecological tsunami on a larger spatiotemporal scale. This story is about interconnectivity, our waterways, our economy, and the choices we make. They are all connected in a profound way. There is no simple victory in this war. The scientific consensus is that it is almost impossible to completely eradicate Asian carp in the vast Mississippi River system. The future path is more likely to be a difficult coexistence under management. This means we need to accept the reality that they have become a part of the aquatic ecosystem in the United States, simultaneously using a precise combination of punches, including sustained technological barriers, controlled commercial fishing, and innovative market development, cutting-edge scientific research and wise policy guidance. Suppress their population to the lowest level to protect critical ecosystems such as the Great Lakes, and minimize its impact on local biodiversity to the greatest extent possible. In the end, the lesson of Asian carp transcends national borders. It reminds us that in a world where humans are unprecedentedly connected to nature, we need more humility, forward thinking, and more flexible solutions. Prevention is far better than cure, and strict risk assessment procedures must be followed when introducing alien species. We are not just facing a fish, but a complex future shaped by our own behavior. Transforming threats into opportunities requires not only the wisdom of technology and business, more need for a profound cultural and cognitive transformation. This battle against the silver invaders. Ultimately, it will define how we coexist with this dynamically changing world full of unexpected consequences. And it provides a rich and thought-provoking case study for the global response to similar biological invasion challenges.